Okay, good morning. Or whenever you're watching this video is being recorded in the morning, so I've got a cup of coffee here with me to get me through our discussion on sections 4.1 and 4.2. This is a review sheet I wrote last year that worked well, kind of regrouping all the thoughts of 4.1 and 4.2, all four of the daily videos that Mrs. Elias has put out, and to help us do that and then do some practice problems around it. These practice problems are exactly the type I would be putting on a test. I'm going to be honest at this point, your test isn't for another week out. I have not quite figured out how I'm going to test on this material. This is something I would normally be making you give me graphs on, and how we're going to do that in this online format, I have not 100% wrapped my head around yet, so I can't give you the pointers. Well, on the test, make sure you do this, make sure you do that. I really don't know yet how I'm going to test on this. This video is being recorded on the day you're actually taking your Unit 3 test. So I am thinking ahead on how we're going to look at Unit 4, but it'll be interesting how we kind of piece all this together. Okay? So the translations of the sine and the cosine is what the whole review is going to be about. We're going to look at it from the big picture of 4.2, noting that in 4.1 we didn't have the actual translation pieces still. But we now do at the end of 4.2, so those are going to be a part of this review. My recommendation to you is to try this review first, and then go back and follow along with me to make sure you got everything correct and understand the key concepts. So if you haven't done it yet, I'd recommend hitting pause, going back, filling this out, using your notes if needed to pull this information together so that you're ready for the test on Chapter 4, sections 1 and 2. So, the translations of the sine and the cosine. For both of them, they are in the form y equals c plus a, our function, I'm going to make this one the sine, times sine of b times the quantity x minus d. Now in the calculator, all these numbers would have to be in a parenthesis, so it's the sine of that whole component. The cosine's the exact same thing, only using the function cosine. A times cosine of b times the quantity x minus d. In all of these, we had the same pieces, and this line is all from unit or section 1. The absolute value of A is our amplitude, or how high our graph goes up and down from the midline. Our 2 pi over b produces our period, and we take that period and divide it by 4, and that gives us the steps, or the different significant piece of the graph. C and D were added in section 2. C became the vertical shift. And D is our horizontal shift, but we call it our phase shift. That actually then relates into science and waves, and whether they're in phase or out of phase depends on where the crests and troughs line up, or nodes line up in the horizontal direction. So we refer to that as a phase shift. Remember that C will create our new x-axis, D creates our new y-axis, but that the D works backwards. And that is the same as we saw in Algebra 2 with all the other functions, except we were using h and k. H worked backwards, x minus h, and k was somewhere else in the equation, added I think usually at the end. And same thing, These functions all work the same way. So everything we learned in Algebra 2 on shifts of any of the different functions we did shifts on, it was x minus h, and h worked backwards because that was our horizontal shift, and k was our vertical shift, and it was just being added at the end. Put the plus c over here, works the exact same way. Okay, so this is not necessarily new. We're just now doing it with the trig functions. So our graphs here at the bottom. The first four are going to be a review of section 1 graphing. The last four are with the shifts and will be a review of the section 2 graphing. So looking at our first one, first thing we do is dissect the pieces. -2 out front, so that -2 is A. So our amplitude is the amplitude of absolute value of -2, which is 2. And I always write it out like this. And the reason why I do is because then that negative reminds me where my starting point is, or which direction I'm heading. And the sign, I'm starting at the midline and on the coast and heading towards that direction, down because it's negative, up if it's positive. With the cosine, I'm either starting at the top or the bottom, depending on that sign. So I always write all this out, even though I can do it in my head just as well as you can. The absolute value of -2 is 2, but that data piece is important, and I can go back to over here in my little summary to find all the pieces I need for graphing. The period is 2 pi over b. In this case, there is no b. There's nothing in front of the x between the sign and the x. So that's 2 pi over 1, which is just 2 pi. The step is that 2 pi divided by 4, and we reduce our fractions. 2/4 reduces to 1/2, or pi over 2. Now we have the pieces we need to graph. We're doing it over 2 periods, so we want one on the positive x and one on the negative x. So our amplitude is 2. That means our graph is going to go up to 2 and down to a -2. And I kind of write my numbers a little off to the side just so they're kind of out of the way when the graph comes chasing through. We have steps of 1/2 pi, so I need 4 steps to the right, 4 to the left. To the right, it'll be pi over 2, or 1/2 pi. It'll be at pi. It'll be at 1.5 pi's, or 3 pi over 2. And it will be at 2 pi. To go one whole period is 2 pi. And we do the same in reverse. -pi over 2, -pi, -3 pi over 2, and -2 pi. Try to keep these spacings as equal as possible. And now to draw the graph, sine always starts at the origin, and we either go up, in our first step, we either go up to the top or down to the bottom. The sign on A tells me that. So it's negative, which means we're going down to the bottom, so down to the -2, then back to the center, up to the +2, back to the center. So curve through the down, curve around up, and curve back to the center. Same thing in reverse. We're heading back up. We got to head up to the top, back to the center, down to the bottom, back to the center. So our graph goes up and back and down and back. Okay? And that's our first one. Second one, we have 3 sine pi x. Excuse me. Our amplitude is Out front, it's the 3. Absolute value of 3 is 3. The period we have for b is pi this time. So our period is 2 pi over pi. Our pi's cancel out this time. That's not a normal period for us, but the math's still very easy to do, and it actually makes the scale easier because you're not thinking in fractions of pi. So our period is 2, which means our step is 2 divided by 4, or 1/2. So that means our amplitude goes up to a 3 and down to a -3, and our steps are at 1/2, 1/2, 1, 3/2, 2, and the same on the negative, -1/2, -1, -3/2, and -2. This is a sine function again, so we're starting in the middle, but in this case, +3 meant we had up to 3, back to the middle, down to a -3, and back. So that amplitude's giving us a higher wave on a different scale, of course, because now this is 2 pi, so this is actually a longer graph. We just have the luxury of being able to adjust how big we're making the gaps here. And then back. Down to -3, back to 0, up to +3, and back to 0. Try to make them as curvy as possible. Try, like this good curve, try not to make them points. They're not points, right? They're waves. Next one's a cosine, but the parts still come out the same. The amplitude is the absolute value of 4. The period, there's nothing multiplied by x, so it's just 2 pi over 1, which is 2 pi. And so 2 pi divided by 4 is pi over 2. So we set this up. 1, 2, 3, 4 to the top, and 1, 2, 3, 4 to the bottom, -4. Steps are 1/2 a pi, so we need 1/2 a pi, pi, 3/2 of a pi, and 2 pi. Same in the reverse. -pi over 2, -pi, -3 pi over 2, and -2 pi. Excuse me. Cosine starts at the top or the bottom depending on the sign on A. So in this case, it was a +4. We're starting at the +4. And we come back down to the middle because there's no place else to go but down to the middle, and then bottom out at -4, back, and remember, this is a curve coming out, heading down, coming around, heading up, and curving around. Same back in the reverse. It's a mirror image over the y-axis. Back, down, back, up, and we get our cosine function. Take a minute for you to look at that, and then we're going to switch to the next page. Next page. Number 4. Our last review problem from section 1. -3 cosine 2 pi x So our amplitude is the -3, so the absolute value of that is 3. Our period, 2 pi over b, in this case b is 2 pi, so 2 pi over 2 pi is a 1. And our step is 1 over 4. Got the pieces for our cosine, amplitude of 3, up 1, 2, 3, down 1 to -3. Our steps are a quarter, so 1/4, 1/2, 3/4, and 1. -1/4, -1/2, -3/4, and -1. And then our graph. Amplitude was started with an A of -3, so cosine starts at the bottom, at the trough. You remember your wave parts. And then we go up to a node, up to a crest, back to the node, and back down again. So curving out and up and over, and like a roller coaster and down. And then the mirror image. Back, up, back, down. Okay, and that concludes the examples from section 1. The next 4 examples are examples from section 2. So we have vertical shifts and phase shifts. So let's look at those. And we're only going to do these over one period. Okay, we may start on the left side on the -x because we have a shift to the left. Otherwise, everything will be on the right for these graphs. So the first one, our amplitude is the number in front, directly in front of the function, so it is the -3 in this case. Absolute value -3 is 3. The period, B, is in front of whatever is potentially in parentheses or in front of the x. So in this case, the period is 2, is a B, or, sorry again. The period is 2 pi over B, or 2 pi over 2, which reduces to pi. Step is still that period divided by 4. Vertical shift is C. There's nothing being added out front here. This is being multiplied, so there's no number being added out front. So C is 0 in this case, which means there is no vertical shift. The phase shift is inside the parenthesis, or what's being done to the x on the right side of it. And in this case, that D is a pi over 4, and that means we are going to the right, because it's minus, it looks like a minus, so it looks like we should go left pi over 4, but that's really, the minus is already part of the equation. So we are moving to the right pi over 4, because the sign inside the parenthesis was negative. Okay? So we do have a phase shift to the right, pi over 4, which means when I start drawing here, I'm going to put pi over 4 in. That's my first step. And that is where I'm going to create my new y-axis. And then I need a full period, 4 more spots from this point. So pi over 4, next one will be pi over 2, or half a pi, quarter pi, half pi, 3/4 pi, then pi, and then after 4, because that's 4/4 of a pi, and then 5/4 of a pi. So to get all the way for a period of pi starting at a quarter, I have to go all the way to 5 quarters. And I have an amplitude of 3. Since there's no vertical shift, it's simply up 3 and down 3 from the origin. So this is a cosine, so we start at top or bottom. In this case, we're starting at the bottom on the new axis. And we are going from there back to the midline, up, back to the midline, and down. Oops, and I missed. Sorry about that. For number 6, we dissect those pieces. It's a negative sign out front here, so it's like a -1 sign. So amplitude's a -1, absolute value is 1. Period, there is nothing in front of the parenthesis here after the sign, so it's just 2 pi over 1, which is 2 pi. Divide that by 4, 2 pi over 4 gives me pi over 2, half a pi. And the vertical shift, in this case there is a C. C equals 2, so it is an up 2 shift. And the phase shift, there is a positive pi over 2 in there, but remember that we have to do the opposite because there's a negative in the given equation. So it's really a negative pi over 2 for D, which means we are going to the left by pi over 2. Hopefully always our phase shift and our steps are multiples of each other because that makes graphing far more easy. So we're going left pi over 2 means 1 step to the left, negative pi over 2 is where our y-axis will be. And our vertical shift is up 2. So up 2 creates for me the new x-axis, or the new center line for the wave. And then our amplitude from there is 1. So we go down to 1 and up to 3. So it's a really short wave. We have to put in the rest of our steps. They're at half a pi each, so negative half pi. Our next step is 0. Our next step is a positive half pi. And then another half a pi gives me pi. Another half a pi gives me 3 pi over 2, and that's 4 steps. 1, 2, 3, 4. So that's as far as we have to go. So this is a sine function. It starts at the origin, which is now here with our new x and y axis. And it's negative, so we're going down first, then back to the midline, then up, then back to the midline. So it's a very flat sine wave. Okay, everyone's got that. I'll flip the page. Number 7. Amplitude is the absolute value of the positive 3 out front. The period is the number in front of the x, so 2 pi over that 3, and it doesn't reduce, so it's 2/3 of a pi. Steps are going to be a quarter of that, so that's 2 pi over 3 times 4, or 2 pi over 12, and that reduces to pi over 6, or a sixth of a pi. So a little bit different fractions we'll be dealing with this time, but nothing we haven't seen already. Vertical shift, in this case C equals a -2, which means the three dots, if you don't know the three dots yet from geometry, three dots means therefore. Okay, so therefore if C is -2, therefore we're going down 2. That's why I keep writing that, just in case you didn't. And I don't know why I'm waiting till the 7th round to tell you that. Phase shift, D was 0, so there is no phase shift, none. Okay? So we're just going down 2 to give us our new x-axis, our new center line. There is no phase shift, and each step is at pi over 6. So 1/6 of a pi, 2/6 of a pi, 2/6 reduces to a third, so pi over 3. 3/6 of a pi is half a pi, and 4/6 of a pi is 2 pi over 3. Oh look, we went 2 pi over 3 in 4 steps. Exactly what we want. Our amplitude is 3, so from -2 up 3 takes me to a +1. And the bottom of this wave is going to bottom out at -5. It's a cosine, so we start at a crest or a trough, peak or a valley. In this case, it's the positive, so we start at the top, starting at 1. In the first step, we go down to the midpoint. Second step, down to the -5, back to the midpoint, back to 1. So I hit all the points this time. There we are. And the last one, it's a sine function. And you know I don't even pay attention to whether it's a sine or a cosine until I'm about to draw on that graph. Because honestly, it doesn't matter until then, right? So, our amplitude is a 3 out front. I really liked a lot of 3s when I was doing this worksheet. Our period is going to be 2 pi over 1/2, which is the same as dividing by a fraction you can multiply by its reciprocal. So that's 2 pi times 2 over 1, which means that's 4 pi. Our step is 4 pi over 4, which is just pi. So nice easy steps. And our shifts. Our vertical shift, the C value was a +4, which means we're going up 4. In the phase shift, it's being shifted by the opposite sign, so it's really being shifted a -pi. It looks like a positive, so we always think we should be going to the right, but really it's to the left by a pi. And we go to graph. So let's put in our new axes. So we're going up 4, and I have an amplitude of 3, so I gotta get 7 on this line total. 1, 2, 3, 4 is where my new axis is. And my left pi, which is 1 step, so I'm going back to a -pi, and my axis is there. Okay? My steps are pi's, so -pi, 0, pi, 2 pi, and 3 pi gives me 4 steps. And then my amplitude of 3 means I'm going from 1, 3 below 4, and up to 7. It's a sine, so it starts at the origin, positive amplitude, so up to 7, back down to 4, down to 1, and back to 4 again. So up, over, down, and over. Okay? And there is our review on sections 4.1 and 4.2 on the graphing and translating of the sine and cosine functions. Thank you.